Welcome to this episode of Night Sky News for October 2021 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the coming months, and we chat about what's been happening in space news in the past month. We're actually celebrating 3 years of this YouTube channel today and 3 years of making these kind of videos as well. So I just want to thank you all just for being here and being curious. Anyway, back to today's video. There's going to be chapter titles down below if there's any specific news story that you want to skip ahead to, and any scientific research papers I mentioned will all be linked in the video description down below. So without any further ado, let's start and kick things off by looking up. All right, the day this video goes live on Thursday, the 21st of October, is the peak of the Orionids meteor shower. So this is meteors or shooting stars that are going to appear to all be coming from the constellation of Orion. So this should be visible wherever you are in the world. However, the full moon this year is going to make spotting these meteors a little bit difficult. It's not the most active of meteor showers. There's only going to be between about 10 to 20 meteors per hour. And because the full moon is so bright, it's going to wash out the fainter ones, so you won't see as many. But if you still do fancy chances and, want to see if you can spot some meteors, and the best time to do it is tonight, going into Friday morning, the 22nd of October. So after midnight tonight and before dawn on Friday morning is the best time you should look. So either, you're an early riser and you get up and you spend an hour looking at the sky before you start your day, see if you can spot any meteors, or maybe you go to bed late after, doing a time lapse or something, or trying to capture some shots of meteors streaking across the sky. As always, if you do capture any, send them my way because I'd love to see them. Then on Monday the 25th of October, in the early morning sky, look out for Mercury from an hour before sunrise onwards, because it's going to be reaching its furthest distance from the sun, from our perspective here on Earth anyway, something we call its greatest elongation. That means it's going to rise a decent amount of time before the sun rises and washes it out, so you've got a lot longer to spot it than you normally would. And considering the fact that Mercury is quite small, it's quite faint, and so it is a little bit difficult to spot, and so this is the best time to view it. Now, those of you that are quite far south of the equator are probably going to struggle with this one, and that's because of the angle that the ecliptic is going to make with the horizon. So the ecliptic is essentially the plane of the solar system, and it's the path that all solar system objects take through the sky, so the sun through the day and the planets at night. And you can see that angle is just really shallow, and so it means Mercury is not very high by the time the sun rises. But as you get further north, the angle actually gets steeper, so Mercury is around longer before the sun rises and spoils the party. So if you think you are going to have a good view from where you are, keep an eye out on the eastern horizon. So, from whatever window of your house gets the morning sun, look out of that window and see if you can spot it towards the glow of the sunrise. Remember, it can be quite faint, so you might need an app to spot it if you're not sure what you're looking for. Then, on Friday the 29th of October, the tables are going to turn, because the southern hemisphere, you're then going to have the best view of Venus for a few hours after sunset as it reaches its greatest elongation from the sun as well. And as you go further north, the angle isn't great, so you only have an hour or so to spot it. Venus is much brighter than Mercury. It's one of the brightest things in the sky after the sun and the moon anyway, so it should be relatively easy to spot as you look towards the sunset in the west from whatever window in your house gets the afternoon and evening sun. From the brightest planet, though, to one of the faintest, because it's also going to be the best time to spot Uranus this month on the 5th of November. Remember the 5th of November, gunpowder, treason, and Uranus. Uranus will be at opposition on the 5th. That means it's directly opposite to the sun in the sky from our perspective, and so it means it's perfectly lit, but also visible all night from wherever you are in the world, rising in the east at sunset and setting in the west before dawn. Uranus is really faint though, so you can't actually see this with just your eyes. You need binoculars to spot it, and it makes finding it in the first place quite difficult. So I'd recommend downloading one of those night sky apps, the kind that you can move around and the sky moves with it and it shows you what you're looking at, so you at least know that you're pointing in the right direction, so that then you can get your binoculars out and try and find it. I'd really recommend, if you have a telescope, breaking it out for Uranus. Because if you do that, you'll see its classic bluey green colour, and it'll be fuzzy edge, not crisp like a star. That alone is just worth the effort of trying to find it. Then something just that little bit easier to find now, because they're really, really bright, and that is Jupiter and Saturn. And you're going to be helped out by my favourite thing, a crescent moon, or a toenail moon as I call it, on the 9th and 10th of November. So in a few hours after sunset towards the west, you're going to have the crescent moon just to the right of Jupiter and Saturn on the 9th. The moon will then move so that by the 10th it'll be just under Saturn, and then by the 11th it'll be just under Jupiter. And that's actually when it's going to be getting close to a half moon rather than a crescent. It should make spotting Jupiter and Saturn that much easier for you, especially if you don't know what you're looking for, right? Because the moon's just going to be this great big bright blaring beacon. But once the moon's moved on, you'll then still be able to recognize Jupiter and Saturn because you'll know where to look from your house. Jupiter will always be the brightest, and Saturn will have that sort of yellowish glow to it. If you have binoculars, they'll reveal the little 4 Galilean moons around Jupiter that are nice and bright, but you're going to need a telescope if you want to spot that sort of characteristic sort of coloured bands of Jupiter, or if you want to see the rings of Saturn. That's just what I did this month when I was sent this, which is the eVscope eQuinox telescope from this week's video sponsor, Unistellar. This is a digital telescope, so it doesn't have an eyepiece. Instead, you see what it sees on an app and control it all through the app as well. This is what I do when I go to professional telescopes, professional observatories, right? I control the telescope through a computer and I see what it sees on the screen, right? So this is almost like the closest you get to that experience, but with like an amateur, like back garden telescope. That said, for those of you who do prefer an eyepiece, check out the new eVscope 2, which was launched just a few weeks ago, which has an electronic eyepiece featuring stunning Nikon optics. What I love about it is that you can turn on enhanced vision. And instead of getting a live view, you instead get like a live long exposure, right? The telescope starts tracking and adds together the light it collects to get this long exposure, allowing you to see faint, deep sky objects like nebula and galaxies from your back garden, even in the suburbs of a city. And you can even do real science with it as well. So say, for example, you were observing a near-Earth asteroid, you could share your observations with a professional scientist whose job it is to actually track near-Earth asteroids. So you can be involved with that, which I just think is fantastic. So for all this and more, head to unistellar.com/Dr. Becky. The link is in the video description down below, and you can get one all of your own. Thank you so much to Unistellar for sponsoring this video. And now I think that's enough for looking up at the night sky. Let's come back down to Earth with a bump and chat about what's been happening in space news in the past month. Alright, in the month that we saw William Shatner launch into space, there was also a much more scientifically important launch on Saturday, the 16th of October, and that is NASA's Lucy spacecraft. It's a space mission that's going to do 8 flybys of asteroids in the next 12 years. So that's going to be 1 in the main belt of asteroids between Mars and Jupiter, and then 7 in the little groups of asteroids that are just ahead and behind Jupiter in its orbit around the sun. It's got a few instruments on board, like an imager, an optical spectrograph, and an infrared spectrograph as well, in the hope of trying to figure out what all of these different objects from various different locations in the solar system are all made from. And that will be with the hope of figuring out, well, how did the solar system as a whole form? It's very exciting because never has there been a plan to send a single mission to so many different bodies in different areas of the solar system before. So it's definitely the first of its kind. It'll launch, then it'll do a few gravity slingshots around Earth in 2022 and 2024. Then it'll get it out to the orbit of Jupiter through the asteroid belt. Then it'll investigate the asteroids orbiting ahead of Jupiter before it drops back into the inner solar system for another gravity slingshot from Earth in around 2031. And then it'll get thrown out to the asteroids trailing Jupiter in its orbit. So it's definitely in for the long haul, this Lucy mission, but every mission has got to start somewhere. Now the James Webb Space Telescope is getting ever closer to its start as well, because on the 12th of October, it arrives safely at ESA's spaceport in French Guiana in South America. And that was after a 9,300 kilometer journey all the way from California through the Panama Canal and then down to French Guiana aboard the MN Colibri ship. There'll now be 2 months of just endless checks and preparing for the launch, which is planned for the 18th of December this year. And if you want to know why everyone in the astronomy community is just so hype for the James Webb Space Telescope, then you can check out the previous video that I did and also interviewed one of the ESA scientists involved as well over here. I'll link it up here and in the video description down below. Let's stick with space missions for now and chat about the Bepi Colombo mission and its first flyby of Mercury. So Bepi Colombo is a joint mission between the European Space Agency ESA and the Japanese Space Agency JAXA, and it was launched back in 2018 on the same rocket that the James Webb Space Telescope is going to get launched on actually as well. And it's named after Italian physicist Giuseppe, or Bepi, he was known as Colombo, who was the first person to propose the idea of a gravitational slingshot for a spacecraft. Essentially, a spacecraft gets accelerated by a planet's gravity, and that gives it a little boost of energy to just, send it on its merry way of wherever it's going in the solar system. Bepi Colombo has now done 3 gravitational slingshots, 1 of Earth and 2 of Venus, to give it an energy boost it needs, because otherwise if you just sort of send it in the direction of Mercury towards the sun, all that's going to happen is it's not going to have enough energy to resist the sun's gravity, and it's going to have a fiery death in the sun. So it's now slowly coming into orbit around Mercury. It's going to use 6 flybys of Mercury to do that. The first one was this month, and it should eventually be in orbit by 2025. It's going to really closely study Mercury's structure, its geology, its form, its craters, and its magnetic field as well. Because what we really want to understand is what happens to a planet when it forms and evolves that close to the star that it's orbiting around. We see a lot of these kind of planets very close into their star when we look for exoplanets, so planets that are in orbit around other stars in our galaxy. We see a lot of them very, very close in. We kind of want to know, well, what would the conditions be like? And we happen to have one in our own solar system with Mercury, so studying that can help us understand other planets as well, which is really exciting. It'll also be doing really, really precise measurements of Mercury's orbit as well, which is really important for testing general relativity, our best theory of gravity that we have that Einstein proposed at the beginning of the 20th century. I've done a video before on why Mercury's orbit is a test for general relativity as well, so if you want to watch that, you can check it out by clicking on the link up here or in the video description down below. For now though, Bepi Colombo got its first view of Mercury from its first flyby from around about 1,000 kilometers above the surface, and the detail is absolutely stunning. Along with all those images it also took a load of scientific data using its spectrometers on board as well, looking at the composition of the surface of Mercury, but also the exosphere surrounding it as well. So I'm sure that the teams at ESA and JAXA are going to be kept very busy analysing all of that data in the next couple of months, and it should keep them busy enough for at least 9 months until the next flyby of Mercury that Bepi Colombo does next year. And the last mission to report on is Perseverance on Mars, which I feel like we do every month now on Night Sky News, right? There's always something to report. I think Perseverance needs its own little segment, like Percy time. Perseverance and all the other missions either in orbit around Mars or landed on Mars have actually been in radio silence for most of this month. So from about the 2nd to the 16th of October. And that's because Mars has passed behind the sun from Earth's perspective. It's also why we can't see Mars in the night sky at the moment either, because it's really close to the sun. It's in the daytime sky, so you can't see it. So because the sun is also not just obviously a very bright source of visible light that we can see, it's also a very bright source of radio waves as well. So receiving a radio signal from Perseverance or from a satellite like the Mars Reconnaissance Orbiter or something that's in orbit around Mars would pretty much be impossible, right? You wouldn't be able to detect that very faint signal compared to the very giant glare of the radio sun, right? It'd be like trying to detect a phone light held up next to the floodlight of a stadium. You're not gonna do it. So the team had, a little bit of a rest, I guess, these past couple of weeks because there was no commands sent. I think they sort of sent some commands ahead of the radio silence just to keep it busy, for a couple of weeks. But then, they got to basically spend a lot of time analyzing a lot of the data that they'd had from everything that Perseverance has taken so far. And in that time, a new scientific research paper was published by the team as well. And it's all about what they figured out about the area where Perseverance has landed, Jezero crater. Now, from satellite imagery, we already thought that Jezero was a dried up lake bed. It had all the signs, the kind of similar things that we see here on Earth. It's actually why it was picked as a landing site for the Perseverance mission, because Perseverance's main mission is astrobiology. So a dried up lake bed is probably a very good place to look if you're going to try and find, say, fossilized signs of life. So since Perseverance has landed, it has been surveying the area that it landed and sending back a lot of images. And that imagery has revealed something called scarps, big steep slopes of a jumble of sediment rock and huge boulders that all appear at one side of the crater or the lake bed. We see these things on Earth too, where rivers meet lakes, or at least where rivers used to meet lakes if it's dried up. And it's caused by the fact that the river actually carries a lot of sediment with it and down, and it sort of dumps it in that mouth of the river into the lake in these huge, big, steep sloped scarps. And the cool thing about the ones on Mars is they've got these huge boulders embedded in them. So for the river to be able to carry those boulders down, they're incredibly heavy, so have enough force and energy to do that. The authors of this study have suggested that the only way that could have happened is if there wasn't just water flowing on Mars in the past at some point, but there had been flash floods on Mars at some point. So these results are really exciting, and it will probably change the plan for the Perseverance mission going forward. They might choose to drill into some different rocks or have Ingenuity explore a different area, the little drone that's with Perseverance as well. But not only that, it really does change our perspective of what the early Mars was like. We already thought, yes, okay, when it did have a thick atmosphere, water probably did flow on it. The idea of not just like a trickle of water, but flash floods on Mars, that really changes the game. The next story I want to talk about is a little bit more physics news than space news. I guess you could say it's astrophysics adjacent in a way. And that is that the 2021 Nobel Prize in Physics was awarded to Sakura Manabe, Klaus Hasselmann, and Giorgio Parisi, essentially for making physics sense out of chaos. Fundamentally, at its core, physics is about randomness and the chaos that ensues because of that. So whether that's at the tiny quantum mechanics level, or whether it's the randomness of the thermal energy of different particles, or even the fluctuations that happened in the soup of hydrogen gas in the early universe that seeded the formation of stars and galaxies through gravity. But it can also be applied to particles of air in our atmosphere, and specifically how they behave, how heat is transferred. It's a very chaotic system. So Manabe worked on making the first computer model of this chaos of the atmosphere and used it in the 1970s to show that temperatures increase with increasing carbon dioxide levels. The two are correlated. Then 10 years later, in the 1980s, Klaus Hasselmann improved the model further to connect climate with weather, showing how an unpredictable, chaotic system like the weather could be birthed by another unpredictable, chaotic system like the climate. He also managed to figure out a way to determine whether a change in the climate was actually due to a natural process or something that was direct due to human influence. And that method was actually used later on by other people to show that increasing temperatures that we've seen over the last century is caused directly by an excess of carbon dioxide produced by human activity. Giorgio Parisi, meanwhile, in the 1980s, discovered patterns in disordered systems, kind of like the shapes made by huge chaotic flocks of birds, right? There's order within that. That discovery had a huge impact across the entirety of physics. I don't think there was a field that wasn't touched by that discovery, from how planets form to how fluids flow. It all fed into those different areas. So all three of the laureates came under that header of understanding chaos this year. And it wasn't necessarily what I would have called for the Nobel Prize this year. I knew it wasn't going to be my beloved astrophysics because astrophysics has actually won 3 of the past 4 years worth of Nobel Prizes as well. So it was supermassive black holes last year and exoplanets the year before that. And then the year before that and the year before that, it was for gravitational waves. There was actually this really cool infographic that I found from Physics World magazine showing how many prizes the different fields in physics had won, at least up to 2018 this infographic goes to. So my money was actually on quantum physics because it hadn't won one in over a decade. But what do I know? It wasn't to be, it actually went to the physics of chaos instead. I don't know. Better luck next year, quantum physics. And finally, I want to talk about one more thing, and it's not the weird radio signals coming from the center of the galaxy, because I want to do a whole video on that in a couple of weeks. I think that needs like a full thing rather than just a little segment in Night Sky News. So look out for that. Instead, it is still about radio waves, but this time we think it's coming from the aurora of some stars. So this was detected by the LOFAR radio telescope in the Netherlands, which is this huge array of radio antennae, stretching across 2,000 kilometers of Europe. And they recently had their first big data release, which I did a whole video on again, which I'll link up here and in the video description down below if you want to check that out. And essentially all of these antennas spread across these huge area added together to give you a telescope that is essentially 2,000 kilometers wide. And the bigger the telescope, the smaller the thing that you can see. It increases your resolution. So with this increase in resolution and sensitivity, a team led by Joseph Callingham at Leiden University managed to spot 19 dwarf stars emitting radio waves in the data that's been released. Now, if you have a very active star that's pulsating, you actually do expect a lot of bright radio emission from it. And that's because, if it is pulsating, it tends to also be throwing off a lot of material into its hot corona that surrounds it. The thing that you can see around the sun during a total solar eclipse when the main light from the sun is blocked, you see this sort of almost halo surrounding that's actually hotter than the surface. And that is essentially made of a lot of high energy particles, including a lot of free electrons, like freed from atoms that then roam freely around in this region where there's also incredibly high magnetic fields. And if you've got electrons moving magnetic fields, this is how you produce radio waves. But when Callingham and collaborators actually looked at the stars that they'd observed these radio waves coming from, they found that 4 of them weren't active. And so the usual explanation there for what could be producing these radio waves doesn't hold. Instead, what they think is the most likely scenario is that these radio waves are actually coming from aurora on the stars. So aurora, like the northern and southern lights here on Earth, which also emit radio signals, right, are caused by solar flares. So these big burps of high energy charged particles from the sun that stream into space, they get funneled by Earth's magnetic field down to the poles where they interact with atoms in our atmosphere, causing them to glow in very specific colors. This happens on lots of other planets too. Saturn has a very beautiful aurora, as does Jupiter, but Jupiter's aurora is like extra strong. It doesn't just have to rely on the charged particles streaming off the sun to produce its aurora. It has like an extra side source of charged particles from its moon, Io. So Io is incredibly tiny, but it orbits very close to Jupiter. So it's constantly getting like squashed and stretched by Jupiter's gravity, which means that the inside of Io is incredibly turbulent. It's very active, and so you get lots of volcanoes on Io that spew out a lot of high energy particles into the region around Jupiter where there's very strong magnetic fields, and so it gets funneled to the poles to fuel a very strong aurora on Jupiter. Jupiter's aurora is so strong that like amateur radio telescopes, the kind that you can like cobble together with a bit of kit in your back garden, can actually detect the radio signals coming from it. Like, it's incredible. So Callingham and collaborators think that something similar to this Jupiter-Io situation is what's going on around these M-dwarfs. If they've got a planet in orbit around them really close, that'll probably be volcanic for the same reason, because it's being squashed and stretched all the time, then it'll be throwing out material that gets funneled by the star's magnetic field to the star's pole, causing an aurora and radio signals that the LOFAR telescope has then detected. So to confirm whether there is actually a planet around these dwarf stars, they're going to need a lot more observations, probably with optical telescopes like, for example, the TESS spacecraft, which is a dedicated exoplanet hunter. It actually looks for dips in brightnesses of stars that are caused by a planet passing in front of a star and blocking a little bit of that light. But you could also follow up this work with more radio observations as well, because if it is an aurora that's generating these strange radio signals, you know, that's thanks to a planet being very close in orbit, then as the planet orbits the star, the signal should actually get stronger and weaker as the planet is on the near and the far side of the star from our perspective on Earth, you know, if it's sort of like in front or behind the star. So if you detect a pattern to the radio signals that you receive that's sort of like a very regular repeating stronger and weaker periodic signal, then you know that this must be because there is a planet that's giving it the material to generate an aurora that gives us these radio signals. And that's really exciting, because then that means that this could become a whole new way of detecting exoplanets that we've never been able to use before. And that is very exciting. All right, that's it for this month's night sky news. You can follow me over on social media if you want to catch up with the latest space news, or if you want to send me a picture that you've taken of the night sky. Although I will warn you now, my social media is going to be absolutely flooded with pictures of the night sky in the Maldives in the next couple of weeks. I'm going on a trip there. I'm just really excited to travel again, to be quite honest, but to see the night sky from there as well. I'm so excited, and there's going to be a video on that on my channel in the next couple of weeks as well, so look out for that. But until then, everybody, happy stargazing. Oh my god, it's so heavy. I forgot how heavy it was. And if you want to know why everyone is so excited for the James Webb Space Telescope, oh, we're going to the Maldives. Oh, it's in the middle of a very big ocean.